Okay, guys, so the recording is happening now, so don't say anything too crazy. We won't have the actual other part recorded of the lecture today. We're only going to record the, in terms of recording, we're only going to record the discussion, or not the discussion. We're not going to record the discussion. I have to get my words straight there. I'm kind of out of it today a little bit. I moved into my new office today, so I'm in there right now. That's why I don't have a webcam. Also, apologize if the mic quality is a little worse. I don't have my nice mic set up in here either. I'll probably get one eventually for the office, but in the meantime, I'll make a decision as to where I want to do these from now on. But I had to move in today, so that's why it's kind of like this today. It looks like I shared the wrong file, so I'll go ahead and share the correct file this time. Okay, does everyone see the file right now? Make sure they've got the correct file shared.
Yes.
All right, appreciate it. So yeah, today we're going to pick up where we kind of left off last class, where we discussed the different, some basic risk analysis. We did some really basic examples. But in a business sense, you're not likely to see any examples that basic. And in addition to that, you're probably not likely to see any examples that basic in class either, in terms of exams. So, I want to make sure you guys are well prepared for the exam. Now, having said that, I'm not going to give you a problem quite this long on an exam, but this is a general format, and these problems do a great job of kind of illustrating the thought process behind how you'd go about solving these. So, I'm just going to take this one from the top here. So we kind of know at the basic sense what we're trying to do. We're trying to compare the cost of acting and the cost of, kind of accepting the risk or transferring the risk or mitigating it. We're trying to determine which one of those makes the most financial sense. So this is kind of like if you're at a grocery store and you're comparing different products. Someone jump in here and tell me, how do you make sure you're getting the best value for your money? If you have 2 cans of beans, they're different sizes, and you want to see which one is the best value, how do you do it? So anyone want to jump in and tell me how you'd compare prices, to make sure you're getting the best value on maybe cans of beans, maybe, anything, how would you do it?
Would you pick them up and compare the two?
Yeah, and if you're going to compare the two, what you'd probably do is you'd probably try to figure out, okay, I've got these 2 different quantities and I have these 2 different prices. You do some sort of a standard measure. So typically we'd use something like a unit price per ounce. Well, this is really the same concept within what we're doing today, where we have 2 different things that have completely different units. We may be dealing in 100-year units, we may be dealing in, all these maybe 10-year units, maybe annual units. We want to get everything to the same unit. So just go ahead and think about that as we go through this. That's what we're trying to do. The end goal is to have 2 directly comparable things. So I'm just going to start reading this. And just to clarify, everyone can see this Word document? Okay. Certainly let me know if you can't. That'd be a big problem. Let's just go ahead and read it. So it says, business firm Clearwater has an infrastructure in place that is valued at $1 million. As is, if the facility is hit with a fire, the value will decrease by $800,000. This is expected to happen once every 100 years. A fire suppression system will cost $250,000 with annual operating cost of $10,000. The fire suppression system will last for 25 years and will cause any fire to only cause $100,000 worth of damage with the same likelihood of occurrence. So what should Clearwater do? Okay, now I'm going to go ahead and kind of work this one out. So as we're kind of going through this, we see a couple important things. First, we see the asset value is $1 million. And further, it also gives us the cost of occurrence to be $800,000. So let's just go ahead and highlight that number. And, right off the bat, we probably want to go ahead and talk about what's the cost of occurrence. So cost of occurrence in this case is going to be $800,000 because that's given right here. The value will decrease by $800,000. So we're just going to go ahead and type in 100,000. And in addition to that, it's not going to happen every single year. This is expected to happen once every 100 years. So in other words, we know that the likelihood of occurrence going to be equal to 1%, or basically 1 out of 100 years. So we're just going to go ahead and simplify that to 1%. And we want to determine what is the annualized, cost of occurrence for this scenario. So as you remember from last class, all we have to do to calculate the annualized cost of occurrence is just to multiply 800,000, which is the cost of occurrence, times the likelihood. So we're just going to take 800,000 multiplied by 1%. And of course, that gives us $8,000. Any questions so far? Certainly do feel free to jump in if you have any questions. That's not a big deal. And that's all we need to do so far. So I'm just going to go ahead and separate that out with a nice little line there. And now let's go ahead and see what we're comparing to. So we see that a fire suppression system will cost the firm $250,000 with annual operating cost of $10,000. So right off the bat, we have an initial upfront cost of protection. That is going to be equal to $250,000 because that's given in the problem right here. So the upfront cost, in other words, day one expense is going to be $250,000. And in addition, we're also going to realize annual operating cost of $10,000 for 25 years. So what we can do is we can take the annual operating cost and go ahead and multiply it out by the length of time that we're going to incur those costs for. So I'm just going to go ahead and first write down annual operating cost. It's going to be equal to 10,000. And then we have lifespan operating cost. And that's where we simply take the annual operating cost and multiply it by the lifespan. And of course, this is good for 25 years. So we take $10,000 multiplied by 25. That gives us $250,000. And, I do like to keep the numbers pretty easy to work with on the exam. I'm mainly making sure that you're kind of aware of the process behind it rather than, seeing how good your calculator is. So that's kind of my philosophy on that, just so everyone's on the same page there. So we have now initial upfront cost of protection, and we also have the lifespan cost. So what we want to do now is we want to get the total cost of fire protection. And that's going to be equal to the initial upfront cost as well as the lifespan operating cost. So we're just going to add those two together. And that's going to give us $500,000. Now, we're not done, though, because this doesn't actually reduce the likelihood of a fire. It simply makes it do less damage. So we want to go a little bit more, and we want to then say, what's the new cost of occurrence? So the previous cost of occurrence was $800,000. This is going to cause any fire to only do $100,000 of damage. So we have the new cost of occurrence, and that's going to be equal to $100,000. And it's not going to change the likelihood of occurrence. So we're going to keep the same light. In fact, I'm just going to copy this because it's easier. So, in other words, having sprinklers doesn't make a fire less likely to break out. It just makes it do less damage. That's kind of what this problem is saying. You could make an argument, but you just go by what the problem gives you, basically. So now we have a new annualized cost of occurrence. We want to calculate that. And as we did before up here, we would take the cost of occurrence and multiply it by the likelihood. We're going to do the same thing here. So we're going to take 100,000 and multiply that by 1%. And that's going to give us $1,000 per year. So if we were only comparing the annualized cost of occurrence to this cost of occurrence up here, we would certainly want to have the fire protection. But we're not done yet. In addition to that, we really kind of missed this step up here because we didn't ever annualize this number, the total cost of fire protection. So let's go ahead and do the annualized cost of fire protection. And what we do is we take this 500,000, divided by how long the system is good for, which is given in the problem as 25 years. And that, of course, is going to give us $20,000. So now, to get the total annualized cost for protection, we simply add in the annualized cost of fire protection to the annualized cost of occurrence with fire protection. So we take the $20,000 we just calculated, and we add in the $1,000 for the annualized cost of occurrence. That, of course, gives us $21,000 for the total annualized cost of fire. Okay. So with that in mind, we can now compare these numbers. These are the same units. They're both annualized numbers, and we can easily compare. So if we keep what we have, our annualized cost of occurrence is expected to be $8,000. And if we engage the fire protective services, the fire suppression, whatever it's called, we're estimated that we're going to spend $21,000 per year. So since the annualized cost of occurrence is less than that, we're just going to go ahead and basically take the protective measure there. So let's just say something like, given the lower annualized cost of occurrence, doing nothing, we accept the risk and do not install the fire suppression system. So you'd say something like that. So that's pretty much how you work one of these problems. Any questions? Anyone unclear about how I got any of these numbers? Any of the steps at all unclear? Any questions at all? Feel free to jump in. Okay. So now I'd like to give some of you guys the opportunity to do some extra credit. So I'm going to actually have some of you guys tell me what to do on some of these problems. So I'm going to go ahead and read this off, and then I'm going to ask for some input. So Grandpa's Pizza hosts a website. If the website is attacked, the total cost of his organization is $50,000. Currently, Grandpa has no protection against such threats, and therefore an attack is likely to occur 56 times per day. A consultant will provide security that will reduce the occurrence to once every 10 years. The consultant will charge $7,500 per year for this service. What should Grandpa do? Well, really, the question is, what should I do? So someone jump in here and tell me what we want to do first.
Okay, from the last problem, is the likelihood of occurrence 10 years like the last problem, or?
Yeah, so the likelihood of occurrence is actually going to be quite a bit more than 1%, because it's going to be 56 times a day. So, in terms of that, we would actually take 56 and multiply it by 365. But is there something we want to do before that, though?
Okay.
Would you want to just type in your assets, which is 50,000, and start with that?
Well, yeah. So the cost of the cost would be 50,000. So instead of doing it with likelihood first, let's just go ahead and start off with cost of occurrence. $50,000. And like Jordan was saying, next we would take the likelihood of occurrence. And we would simply multiply out 365, because there's 365 days in a year, times 56 times a day. That's going to be pretty likely. So this is going to happen 20,440 times per year. So if you go ahead and annualize this cost, instead of having a percentage, because we typically wouldn't expect it to happen every year, we're actually anticipating this happening over 20,000 times a year. So can someone tell me how we would calculate the annualized cost of occurrence here?
You would multiply the cost of occurrence times the likelihood of occurrence.
That's exactly right, Ben. So we simply take the $50,000, and we're just going to multiply that by 20,440, and I'm not a human calculator. I do have the answers right in front of me for this. It is 1,022,750,000 Yeah, 1,022,000,000, and that's the answer. So that's pretty steep. I think we could probably find some sort of solution for Grandpa here. So let's see here. Someone want to take a stab at what the next step might be?
Now, do you start to incorporate the 7,500 per year for the service, or?
Yeah, exactly. So we go ahead and look at this annual protection cost, which is equal to $7,500. And, that's going to do some stuff for us. Someone who hasn't spoken, someone want to chime in and say, what do we do next? We have the annual protection cost.
Would you times that by 10 years or would you?
So in this case, it's going to happen once every 10 years. So that means that it's going to happen 10% of years. So we go ahead and get the new likelihood of occurrence. It's going to be equal to 10%. Because if it's once every 10 years, that's 10% of years we anticipate this to happen. Make sure I got the extra credit written down. Yeah, so then after that, we go ahead and we, of course, would calculate the new annualized cost of occurrence.
So you just times 7,500 times 0.10?
Exactly. So all we have to do here is take the 70. Well, let's back up, though. We wouldn't necessarily do 7,500. That's the protection cost. So it's not going to change the damage. The damage will still be $50,000. So he's only changing, in this example, the likelihood of it happening. Does that make sense? So in the previous example up here, it changed the damage, but it didn't change the likelihood. In this example right here, it's doing the inverse. It's actually going to change the likelihood, but not the damage. So we still have the same damage, but it's only going to happen 10% of years instead of happening 20,440 times per year. So that's substantially less. I anticipate this will be quite a bit lower. So we take 50,000 multiplied by 10%, or 0.1, depending on how you prefer. And that, of course, is going to give us $5,000. So that's going to be our new annualized cost of occurrence. And that's not the whole picture, though. There's something missing. We can't directly compare those two numbers yet. Anyone who hasn't gotten some credit today, you want to jump in and say what the last step is to make sure we can directly compare these? So what are we going to do right here to calculate the total annualized cost for protection?
Do we need to add the 5,000 and the 7,500, or?
So 7,500?
Well, I know 5,000, right? That's what we used above.
Yes. So what we're going to do is we're going to add in the annual protection cost, and we're also going to add in the new annualized cost of occurrence. So we're going to add in the 7,500 and the 5,000 together. That's going to give us a directly comparable number. So that's going to end up equaling $12,500. And based upon this, it should be pretty obvious. But someone who hasn't answered yet, you want to chime in and say what we would do? Do we keep everything as is, or do we mitigate the risk?
Yeah, I'm no mathematician, but I'm pretty sure we would mitigate it for a fraction of the price.
That's exactly correct. You have 12,500 versus $1 billion. I mean, it's probably more sustainable to engage in the mitigating behavior there. And you could write out a whole big statement there, but if you understand that, you understand everything else. So any questions about this? Any questions at all? Any math steps not clear? Any steps at all? Okay, I've got one more problem I want to go through, just to kind of show some different things. Like this problem's a little different than this problem, because in this problem, like I say, we're not actually changing the likelihood of occurrence. We're only changing the cost of occurrence. Whereas in this problem, it's the opposite. So let's do one more. Let's see what's going on in this example right here. Boy, don't I pick some strange names for some of these. Anyway, so the example says, Yippee Yarn You Love has a customer database which it currently protects using reasonable measures. If compromised, they will lose $2,500 or $25,000 in business and pay $75,000 in restitution. This will happen every 20 years. In addition to this, consultants offer to provide additional services that they claim will reduce the probability of occurrence to once every 100 years at a cost of $10,000 upfront for software licensing and $1,000 every year for maintenance and upkeep of the software. The service agreement is for 10 years. What should Yippee Yarn You Love do? So right off the bat, we're going to do the same thing like we did before. We're going to get the cost of occurrence. But this time it's not quite so easy to determine what that is. So anyone want to chime in? I think everyone has answered except for Kyle. You want to chime in and tell us how we calculate the cost of occurrence in this?
Question about that. So is that just going to be for how much you lose, or is it also going to be losing how much you have to pay even in restitution, making it more a total of $100,000?
That's exactly correct, Kyle. So what we do is we'd say they lose $25,000 in business, and they would also pay $75,000 in restitution. So we're actually going to add those two together. And that's going to give us $100,000. Okay. And in addition to that, we have the likelihood of occurrence, which was given to us. If I could spell. Okay, so we see this is going to happen every 20 years. So that's just going to be 1 divided by 20, which is going to give us, of course, 5%. So 5% of years we anticipate this to happen. I just find it easier to work with fractions and decimals than percentages, or, anyway. So, then we're going to calculate the annualized cost of occurrence. And that, of course, is going to be $100,000, the cost of occurrence, times the likelihood, which is 5%, and that gives us $5,000. Okay, is that clear to everyone? So the main difference here is that there's actually not just a direct cost. There's really two costs that we're accounting for. So in addition to this, consultants offer to provide services they claim will reduce the probability to once every 100 years. So tell you what, let's go ahead and get this initial cost. Protection. Call it up front. And that is given as $10,000. That's right here. And of course, we have the new likelihood. That's given as 1 out of 100, which of course is 1%. Yeah, so they're going to reduce the probability right here. Okay, what do we do next? Anyone want to chime in and say what we do next? Let's go.
Now, do you find the annual likelihood of occurrence, or?
So there's really, you could do this in a couple different steps. What I think is, what I'm going to do next here is I'm going to get the lifespan cost for protection. And of course, to do that, we would get the upfront cost and add it in to the maintenance cost. Let's go ahead and calculate the operating cost over lifetime. And that is going to be $1,000 times 10 years. So we're just going to go 1,000 times 10. That gives us $10,000. now we're going to get the lifespan cost of protection, which is going to be this 10,000 right here from the upfront cost, as well as the operating cost. So again, I like to keep the numbers nice and simple. Just add these two together, and that of course gives us 20 grand. Okay, so now we have the lifespan cost of protection, and we want to go ahead and get that into an annualized cost of protection. So just to kind of recap here, we're just going to take this lifespan cost, which is 20,000, and we know the system is good for 10 years. It's given in the problem right here. So we're going to divide that by 10, and that gives us 2,000. Okay, but we're not quite done yet. We still have a likelihood of occurrence, which is right here. In fact, let's go ahead and paste it right here, just so it's more streamlined. And we also have a new annualized cost of occurrence. And, of course, we calculate that by taking the cost times the likelihood. So in this case, it's still going to be 100,000. What is it, 1%? And that gives us $1,000. Okay. So now what we're going to do is we're going to add these two annualized costs together. The total annualized cost with protection. And of course, we add in the 2,000. We add 2,000 for the annualized cost of protection to the annualized cost of occurrence, which is 1,000, and that gives us 3,000. So now we can easily compare these directly. So we have a $5,000 annual cost of occurrence by doing nothing, and if we mitigate the risk, we have a total annualized cost of protection of $3,000. So what do you think we're going to do here? Since it's cheaper to mitigate the risk, do you think we should mitigate the risk?
Yes, since it's cheaper.
Yeah.
I certainly agree. We want to do whatever makes sense, and we want to make sure that we do it well. Any questions about any of these? I'm certainly happy to address any questions. If anything's unclear, I can go over it again. I'm going to go ahead and end the recording right here. We're not done with class. We still have to do the discussion, but I'm going to go ahead and end the recording.